You're welcome. How to solve these systems of equation with three unknowns and using Cramer's rule from here. Let's separate the coefficients to form a 3 by 3 matrix. We have 4 minus 1, 2. Then we have 1, 2, minus 2. And we have minus 1, 1, 1. So we have this matrix, which is a 3 by 3 matrix here. Then the variable here are x, y, z. Then equals to the constant, which is 13, 0, then 5. And from here, to get x, y, and z, x here is equals to delta x, that's determinant with respect to x, over delta, that's over determinant, and y also is equals to delta y over delta, and then z equals to delta z over delta. So we find determinant first. This delta here is determinant. So when you find the determinant of this 3 by 3 matrix, we have the determinant now will be equals to determinant of, we have 4 minus 1, 2, and we have 1, 2, minus 2, then minus 1, 1, 1. So when we find the determinant here, let's expand along the first row, and the sign on the first row is plus, minus, plus. And from here, determinant will be equals to 4 into bracket. We cancel everything on this row and everything on this column of 4. So we are left with this 2 by 2 matrix. And 2 times 1, that's 2. Then minus 1 times minus 2, that's minus 2. Minus minus 2, that's plus 2. Then we have minus 1, that's plus 1. Then into bracket. Here we also cancel everything on this row, everything on this column. We are left with this 2 by 2 matrix, which is 1 minus 2 minus 1, 1. Then we find the determinant of that. 1 times 1, that's 1. Then minus 1 times minus 2, that's 2. Then we have plus 2 into bracket. Here also we cancel everything on the row and this column. Then we are left with this 2 by 2 matrix. 1 times 1 times 1 here, that's 1. Then minus 1 times 2, that's plus 2. Then from here, this will give us 4 times 4, then plus 1 times minus 1, then plus 2 times 3. And here, 4 times 4, that's 16. Then 1 times minus 1, then plus 6. And here, we have 16 minus 1, that's 15, then plus 6, that's 21. So here, the determinant, which is delta here, is equals to 21. And we cannot find determinant with respect to x, which is delta x. Let's find delta x first. Then delta x now, we still use this determinant. We use this, but now we remove the first column and we replace it with a constant. So because the first column there standing for x, so let's remove that and substitute it with this constant, and this will become, so 13, 0, 5. Then we have minus 1, 2, 1. Then we have 2 minus 2, 1. So we just replace, the first column with a constant there. Then that means from here, determinant with respect to x now, when we expand, let's expand around the first row. and that will be 13 into bracket. Here we cancel this column of 13 and this row of 13. We are left with this 2 by 2 matrix. That's 2 minus 1 times minus 2. That's minus 2. That's become plus 2. Then minus, we also have plus, minus, plus. And we have minus, minus 1. That's plus 1 into bracket. Cancel everything on the row and on the column of minus 1. We are left with this 2 by 2 matrix. That's 0 times 1. That's 0. Then minus 5 times minus 2. That's minus 10. That's plus 10. Then plus 2 into bracket. Here we cancel everything on this row and this column as well. Then 2 by 2 matrix. That's 0 times 1. That's 0. Then minus 5 times 2. That's 10. And there, what we have now becomes 13 times 4. Then plus 1 times 10. Then plus 2 times minus 10. And here, 13 times 4 here will give us 52 from here. Then we have 52 plus 10. Then minus 20 from here. 52 plus 10 minus 20. And determinant with respect to x now. This will be minus 10, then 52 minus 10, that's 42. So we have determinant with respect to x here to be 42. And also we can get determinant with respect to y now. Determinant with respect to y, delta y, will be our matrix. That is, we write, the normal one matrix. Then we replace the second column now with the constant, which is 1305. So that's the only thing that we change there. So, and from here, when we find the determinant here now, we are not going to have delta y now to be equals to, expanding along this, row, we have plus, minus, plus, and that will fall into bracket. We cancel everything on this row, this column. We are left with this 2 by 2 matrix. That's 0, 1 times 0, that's 0, minus 5 times minus 2, minus 10, that's plus 10 now. Then minus 13 into bracket. Cancel everything on this row, this column. We have 1 times 1, that's 1. Then minus 1 times minus 2, that's 2. Then we have plus 2 into bracket. Also, cancel everything on that row and this column. We're left with this 2 by 2 matrix. That's 1 times 5, that's 5. Then minus 1 times 0, that's 0. So this gives us now 4 times 10. Then minus 13 into bracket. Here we have minus 1. Then plus 2 into bracket 5. And from here, this gives us 40. Then plus 13 plus 10. And from here, this is 40 plus 10, 50, and plus 13, that's 63 from there. So determinant with respect to y here give us 63 from there. Then let's find determinant with respect to z, and from here we just replace this last column now. We write our normal matrix and we replace the last column. And from there, determinant with respect to z now will be 4, 1, minus 1, that's first column. Then second column we have minus 1, 2, 1. Then the last column now will now be the constant, which is 1305. Then when we find the determinant here, we also expand. Let's expand around the first row again. We have plus, minus, plus. Then this becomes 4 into bracket. Here we cancel the column of 4 and the row of it. So I left this 2 by 2 matrix. That's 2 times 5, that's 10. Then minus 1 times 0, that's 0. Then minus, 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 minus 1, that's plus 1 into bracket. Here we cancel this row, this column. We we are left with this 2 by 2 matrix, and we have 1 times 5, that's 5, minus 1 times 0, that's still 0, then plus, we have 13 into bracket here. You cancel this row and this column, we are left with this 2 by 2 matrix. 1 times 1, that's 1, then minus 1 times 2, that's plus 2. Then from here, this becomes 4 times 10, then plus 1 times 5, then plus 13 times 3. And here 4 times 10, that's 40, plus 5. Then we have plus here 13 times 3, that's 39. And when we sum this together from here, this gives us 79, then that's 84 from there. So 84. So determinant with respect to z now is equals to 84. Now, since we have determinant with respect to x, delta x, we got that to be 42. We got delta y to be 63, and we got delta z to be 84. Then our determinant was gotten to be 21. Then easily now we can find the value of x, the value of y, and the value of z. And from there, x will just be determinant with respect to x over the determinant. And that is 42 over 21. From here, and 42 over 21, that's equals to 2. So x equals to 2, and also we can get y as determinant with respect to y over determinant, which is 63 over 21. And from here, this is same thing as 3 from here. So y equals to 3. And also from here, we have z now equals to determinant with respect to z over determinant. And here, this is 84 over 21. And here as well, this is same thing as 4. So we have z to be equals to 4. And therefore, we can conclude from what we are given using Cramer rule from here that the value of x, y, and z here. So we got x to be equals to 2, and y to be equals to 3, and z to be equals to 4. Using Cramer's rule from here. And thank you for watching. Don't forget these steps. Subscribe for more exciting videos. Turn on the notification bell. Share this video. Give it a thumbs up. And if you have another way of solving this, please put it in the comment section. See you in the next class, and bye for now.